For Lab 7, you will be looking at planetary periods, meaning the period of time it takes for a planet to go around the Sun. Specifically, your lab is looking at Jupiter over a 2-year period, which is a relatively small part of Jupiter's roughly 12-year period. Remember back in Unit 1 of the lecture class, we discussed retrograde motion. Retrograde motion is the apparent backward motion that outer planets appear to have during parts of their orbit as the Earth passes them, traveling at a higher rate of speed. Inner planets exhibit retrograde motion also, but for different reasons. We will use Stellarium to chart this retrograde motion for 2 successive years and use this data to calculate Jupiter's synodic or orbital period. The lab itself is in 2 parts. The first part is the Stellarium charting. Then, in part 2, you will be using the retrograde motion data to calculate both the orbital period of Jupiter and its distance from the Sun. Open Stellarium to get started. Please notice that before you go farther in the video, this map and data set does not match what you have on your lab sheet. That's because I want to walk you through how to do the lab without actually doing it for you. For the purposes of this video, we're looking at what Saturn was doing back in 1997 and 8. You're looking at what Jupiter was doing in more recent times. In any case, what you will be doing is the same process I'm going to do here. Notice that there are 2 sets of data to chart. I'll show you how to do the first one for Saturn, then you will complete both sets for Jupiter on your own. We'll start with the year 1997. Even though that's quite a while ago, Saturn was in a good position near the stick figure of constellation Pisces. That will make it easier to chart than some of the other more recent times in its orbit. The sky map you see here is where I will be charting Saturn's path. The stick figure and area around it you see here is the majority of the Pisces constellation. There's a little bit more to the stick figure over here that looks roughly circular. Notice on this map the Greek letters that indicate the names of some of the stars along the stick figure. I will set my date and time in Stellarium as shown here. You should do the same to follow along. It might be helpful for you to hit the A key on your keyboard to turn down the brightness of the sun so it doesn't interfere with your ability to see the planet. I will use the Find command in the left sidebar to find Saturn. You'll see its location here. Once selected, you'll see a lot of data about Saturn up here, but you don't need that for this lab. Notice the position of Saturn as compared to the V shape of the stick figure of Pisces with the small triangle over here and the circlet over here. Now we need to start charting. Zoom in on your screen to get a closer view of Saturn's area. Notice the small number here indicating a very narrow field of view, meaning that you are more zoomed in. Notice the star that I selected up here above Saturn is named with a Greek letter E. Below that, you see another pair of stars and then another bright one a little farther along the stick figure. Let's compare that screenshot to our map. Can you see the Greek letter E here again? Then the pair of stars, and then the other bright one? This is the area where Saturn is located on your screen, and we want to plot its location as accurately as possible. So back to our screen, notice that if I draw a line segment between these 2 stars, then I make another segment of that same length at a right angle to the first one, I actually hit right where Saturn is. So I want to make that same position visible on my map. So that's what I've done here. You'll notice that I took the same length between These two stars made my right angle and plotted Saturn's location here. If you draw lines while you're plotting, please erase them after you plot the planet's location so you don't have a lot of extra lines cluttering up your page. Now I just have a point where Saturn is on this date, and I label it with the date. Now jump forward a few weeks in time to this new date. Notice that Saturn's location from June 15th was higher and farther to the right than it is in this image. If we draw our right triangle again, a few weeks ago, Saturn was over here. Now, it has moved along this path, and Saturn will continue to move toward the left until about August 1st. Here is Saturn's location on August 1st. You'll see that the screen is angled in a different way than it was before. Since it's a couple of months later in time, the planet is not visible at the same time of day as it was before, so the whole sky has spiraled around a little. I can still, though, compare it to my map if I spin it. This star was the Greek letter E, these were the adjacent pair, and this was the other bright star that was a little farther down the stick figure. Notice that now Saturn is close to the line between the pair of stars and about equidistant to this other star over here, making a thin, obtuse triangle. So I will spin my map around a little to the right. Again, here's the E star, the pair, and the other bright star. Now, on August 1st, Saturn is kind of on this line and about the same distance away from those as it is from this one. Saturn should be about here. I will draw a dot to label Saturn's location and date it 8/1/97. Spinning our map back upright, it should look like this. Now the retrograde motion begins. For the last month and a half, our planet has been marching in this direction. Now it will appear to turn around and go back the other way. Now set your time to the 9/15/97 date. Notice that Saturn is now in almost the same position as it was back in June, across from the pair of stars here, but just a little farther down. So overall, my 1997 path should look like this. Starting in June, traveling left, then turning around and going back to the right, making this sideways V shape. This is actually just showing the start of the retrograde motion. Saturn will actually turn around later and start traveling back to the left later on, though we aren't going to graph that whole path. Now that you have seen the procedure, change the dates to the ones on your lab sheet and complete Jupiter's partial retrograde paths for both sets of dates on your lab sheet to finish part 1 of your lab. You'll get similar V shapes for both your data sets for Jupiter. In part 2, the directions right below your map ask you to Google Jupiter retrograde 2017 Drikpanchang. When your results are displayed, click on the Drikpanchang site. It should be one of the first few results in your display. Be super careful, though, that the date is set properly. Sometimes it comes up on the right year, and sometimes it doesn't. Notice that though I Googled 2017, the result is 2019. You can still click this, but you'll have to change the year. Once the page opens, check your planet and year. Be sure that you're set on Jupiter and 2017. If, like mine, you're set on 2019 or another year, use the Previous Year button to click back to 2017 for your first data set. Once you're set on the right year, this page gives you both dates you need for the first two blanks under the map. The first blank is asking for the date when Jupiter began its retrograde motion, and the second blank is when Jupiter completed its retrograde motion and started moving forward or prograde again. Note that these numbers are not the same as those you plotted on your map, as you only plotted part of the retrograde loop. On your lab sheet, record these dates: when Jupiter began its retrograde motion and when it restarted its prograde or forward motion. Then do the same thing for 2018 by clicking the Next Year button on the website to go to the 2018 numbers. Once you have completed that, you will have all the data you need to do the calculations and will no longer need your computer. Now calculate the opposition dates. The opposition date is the name for the halfway point in that retrograde period. Basically, calculate which date is in the exact middle between the two dates you have for each year. For the rest of the lab, you will step through a few math problems. First, you will find the number of days between the 2017 opposition and the 2018 opposition, your number 4 dates that you have here. Notice that since we're going from 2017 to 2018, it's a little over a year, more than 365 days. You will then convert your number of days into years. You will then plug your number 6 synodic period value P in here to solve for S, the sidereal period. This part tells you how exactly to do that calculation in your calculator if you aren't very strong in algebra. Follow each step carefully to solve for S, the sidereal period, which is the time it takes for Jupiter to orbit the Sun. Once you have this number, you need to check and see if this answer is reasonable. Look up the book value for the sidereal period in the textbook in Chapter 11.2 on the giant planets. Your number should be in the same ballpark. You'll calculate your percent error using this procedure. If your percent error is higher than 10 to 20%, you have made an error. Stop work on your lab and go back and check your work. If you're not sure where you've made an error, email me or come to office hours. You can send me a screenshot of your work, or we can discuss it either in person or in the virtual office. Don't turn in work you know to be incorrect. Ask for help. Finally, once you have this period, plug in your S value, not the book value, into this equation. Again, the number 9 instructions tell you how to solve for D, the distance of Jupiter from the Sun in AU. Then finally, look up the book value for this distance. Again, your number should be quite close to the book value. Calculate the percent error between these two values using the same procedure for percent error you used in number 8. As before, if your number is off by more than 10 to 20%, you've made an error. Ask for help when you get stuck. Better to ask before submitting and get your answers right than turn them in and have to redo corrections later. Good luck with your lab, and please contact me if you have any questions or issues.